This video will walk you through the steps on how to simplify, multiply, and divide rational expressions. Now that you've learned how to graph rational expressions, we're going to look at doing some algebraic operations with them. We're going to first review things that you learned in Algebra 1, and that regards how to simplify rational expressions as well as multiply and divide them by using your abilities to factor things. So when we have rational expressions, oftentimes there are things that you can factor out that'll simplify or cancel out. So if we take a look at the examples here on the screen, let's take a look at some really basic ones, and then we'll look at some ones that take some more factoring involved to cancel things out. So in the first example, you have 15 over 65. Now, we know we can punch that in the calculator, and that'll factor it down. But if we think about it, 15 is the same thing as 3 times 5, while 65 is the same thing as 13 times 5. If I break it apart into those factors of each numbers, we see the 5 over 5 on top of each other. Well, 5 over 5 would cancel, leaving me with a reduced fraction of 3 over 13. Exactly what your calculator would spit out, but that's what it's doing. It's seeing that we can divide a 5 out of each term. Those 5s end up canceling. What you will be seeing is something a little bit more complex with that, with dealing with x's and x squareds and those sorts of things. We're going to be canceling out factors and doing the same thing, trying to figure out what factors are in the numerator and the denominator and what can cancel out. So if we take a look at number 2 here, this problem's already been pre-factored for us. We have 3 times x plus 1 over x plus 1 times x plus 3. In both the numerator and denominator, we have the same factor, x plus 1, so they cancel out, leaving me with a final answer of 3 over x plus 3. Please note, as you may remember from doing this in Algebra 1, we do not cancel the 3's because the 3 up top and the 3 in the bottom are two different types of 3's, if you will. We have the 3 up top, which is just 3. The 3 at the bottom is connected with the x. It's a whole expression. You can't take part of an expression and cancel it with another term because you feel like it. Okay, they both would have to be either x plus 3's or both would just be regular 3's in order to cancel. Now, typically you're going to see problems like 3, 4, 5, 6, etc. moving forward where you have stuff that isn't factored yet. We need to go and use our factoring strategies to break it down to see what will cancel. So number 3, we have 40x plus 20 over 10x plus 30. In both cases, we're going to take a GCF out to see how this factors down. So in the numerator, I can take out a GCF of 20 and be left with 2x plus 1. And in the bottom, I can take out a GCF of 10 and be left with x plus 3. Now, it doesn't look like a whole lot's going to cancel here. The 2x plus 1 certainly won't cancel with the x plus 3. But we can reduce the numbers out in front. 20 over 10, we can simply simplify into 2 over 1, or just 2. So I can rewrite this as 2 times 2x plus 1 over x plus 3. And that would be my simplified answer. Number 4, same idea. Up top, we have a trinomial. So we're going to figure out what factors, what multiplies to negative 15 and adds to negative 2. So you can draw out your little diamond, or you can just kind of do that in your head. What multiplies to negative 15 and adds to negative 2 would be x minus 5 and x plus 3. In the denominator, we'd use difference of squares to break apart x squared minus 9, which would break apart into x minus 3 and x plus 3. We can see top and bottom, x plus 3's are in common, so they'll cancel, leaving me with a final answer of x minus 5 over x minus 3. Again, same deal as number 2. We're not going to randomly cancel the x's. The x's are connected to other terms as a whole expression. The whole thing has to cancel. You cannot cancel parts of an expression. 5, same idea. We've got ourselves 2 trinomials, so we're going to go ahead and break those apart. So up at the top, we need to figure out what multiplies to negative 3, adds to negative 2. X minus 3, x plus 1 will do the trick. Same thing in the bottom. What multiplies to negative 6, adds to negative 1. The 2 values that will do that are x minus 3 and x plus 2. The x minus 3's will cancel out, leaving you with x plus 1 over x plus 2. And in the final example, up at the top, occasionally you'll have an expression that just will not factor. X plus 4, there is nothing to factor, so we're going to leave it alone. X squared minus 16 is a difference of squares, so that becomes x plus 4, x minus 4. The x plus 4's will cancel out. If you have an instance where the numerator has no factors left, there is an invisible factor of a 1. You do need that 1 as a placeholder because you can always multiply whatever's in the numerator by 1 and still have something there. You cannot leave the numerator blank, so our final solution is going to be 1 over x minus 4. So being able to simplify one rational expression is super helpful when we start doing other operations. The operations that this video is going to take a look at are how to multiply and divide, since those should be more of a review to things you've done in previous courses. So let's go ahead and take a look at multiplication. Multiplication is pretty easy to work with. You're basically given two fractions. You basically, in most cases, need to figure out what can cancel out in each fraction. You're going to factor things apart. You're going to have lots of things. Sometimes it'll cancel out. You may only have a few things that cancel. The only difference between this and what you saw in the previous slide was that you have two fractions to work with as opposed to one in most cases. So let's take a look at the first one here. You'll notice this isn't really anything factorable. This is just kind of messing with exponents to kind of reduce things down. So what I'm going to do in this case, since this isn't really factorable, is I'm going to just multiply straight across and combine everything. So in the top, I'm going to combine my numerators by multiplying. 3 times 6 is 18. X to the 5th and x make x to the 6th. Y squared and y squared make y to the 4th. In my denominator, 8 times 9 is 72. X and x cubed make x to the 4th. Y and y make y squared. From here, I'm going to go ahead and just simplify using basic exponent rules and just basic knowledge of division. So I have 18 over 72 gives me 1 over 4. So I'm just going to put a 4 on the bottom. I'm going to now take x to the 6th over x to the 4th. You subtract the exponents in this case and get x squared. Y to the 4th over y squared leaves me with y squared left over. Those stay in the top, the 4 goes in the bottom, and that's my final solution. Whenever we simplify these, it's no different. With any other simplification process, we need everything to cancel out it's supposed to. We don't have multiple of the same base. We reduce as far as we humanly can. What you're typically going to mess with, though, and for the rest of this chapter, especially once we get into adding and subtracting, are problems like 2, 3, 4, and what you'll see with the division, where you're going to have to factor a lot of things apart and see what cancels from there. So let's take a look at number 2. The key in doing this type of problem is factor one thing at a time. Don't try to hop around and do multiple things. Don't cancel as you go. Factor everything first and then simplify. So number 2, I can take out the GCF in the top left. I can take out negative 3x and be left with x minus 1. The bottom left, so of the numerator of my first fraction, it's a trinomial. What multiplies to negative 5 and adds to 4? Be x plus 5, x minus 1. Times, we got another trinomial. What multiplies to negative 20 adds to 1 in the top right. So that would be x plus 5, x minus 4. The bottom right is 3x. That's it. So now what I have to do is, again, technically I would multiply straight across if I just had a bunch of monomial singular type terms. But here I've got a bunch of binomials. I got a bunch of factors. Since I'm multiplying straight across, all I have to do is treat this as one big fraction. So essentially, I'm just going to connect the bar here. Look at the fraction in total. Anything up top cancels with anything on the bottom. Doesn't matter if it came from the first or the second fraction. It's all being multiplied together, so it just becomes one big thing. So we've got a few things that cancel. X minus 1 cancels. So does x plus 5. What will also pretty much cancel out, we have a negative 3x and a positive 3x. The 3 will cancel, leaving me with that negative, and so will the x. That negative we're going to treat as, you can either call it negative 1 and write it like negative 1 times x minus 4, or you can write it as a negative with the x minus 4 in back of it. They both mean the same thing. You'll notice we had no denominator in this case. You don't have to write a fraction over 1, as you well know. You technically can, but since the denominator's disappeared, you do not need that placeholder. Denominator goes away, you don't need to write anything. So we just have the two things up in the numerator, the negative 1 and the x minus 4, and that's my answer, negative parentheses x minus 4. In the case of the third example, we have a fraction times just a singular expression. What I recommend here is, since we have at least one fraction, make the other thing a fraction. So take that x squared plus 9x plus 14, put it over 1, And we're going to go ahead and do the exact same process we've been doing. We'll simplify everything we can. So top left is just x plus 2. Bottom left is the difference of squares, so we'll have x minus 7, x plus 7. Top right, what multiplies to 14 adds to 9, x plus 7, x plus 2. And the bottom stays 1. So once again, I'm going to go ahead and connect my fraction bars, make it one big problem. The x plus 7s will cancel, and that's it. In this case, you have two x plus 2s in the problem, but they're on the same side of the fraction bar. They're both on the numerator. They will not cancel because they're both in the same part of the fraction. So when we write this out, you have one of two options. You can say x plus 2 times x plus 2 over x minus 7. And again, I'm ignoring the 1 because multiplying by 1 doesn't really do anything. Other way you can write it, since there's two x plus 2s, you can say x plus 2 squared over x minus 7. Either way is acceptable, and that'll be your final answer. The last, the multiplication, same process. Top left, I can take out the 2x, be left with x minus 5. Bottom left, I have a difference of squares, so I have x minus 5, x plus 5. The second fraction, I can't do anything with either expression. X plus 3 is the same with 2x squared. So the x minus 5s are going to cancel out. The 2's will cancel, the loose 2's. I have an x over an x squared. What will happen is the x from the top will cancel with one of the x's in the bottom, which means I'll have an x left over. My final answer, I have the x plus 3 up top. In the bottom, I have that leftover x times x plus 5. So that's how you go ahead and multiply rational expressions together. It's a lot of factoring, and in a lot of cases, there's a lot of things that cancel. So if you multiply a couple of rational expressions together and nothing seems to cancel out, there's a good chance you might want to check your work. But typically, at least one pair of factors will end up canceling from the problem. The last bit of this is how to divide. Now, dividing is very similar to multiplying. The only difference is when you divide fractions, and if you read the phrase at the top here, it's going to be very important. If you want to divide two fractions, two rational expressions, you change the division to multiplication and you flip the second fraction, turn it into its reciprocal. So like in the case of number 1, before I do any factoring, since I see division, I'm going to go ahead and make it a multiplication problem. The way that I do that is, again, division changes to multiplication, which means my second fraction I'm going to flip upside down. It's the same problem, and once I convert it to multiplication, I can do the exact same process that I was doing in the previous 4 problems. So I'm going to factor everything apart. So 7x up at the top left, 2 times x minus 5 in the bottom left. Top right is a trinomial, x minus 6 and x minus 5 is how that'll break apart. And then we take out an x minus 6 in the bottom right. So I'll have the x minus 6's cancel, the x minus 5's cancel, and these loose x's are going to cancel as well, leaving me with a final answer of 7/2. The last problem is the same idea. This looks very similar to number 3 from the multiplication problem. So you see that second expression isn't written as a fraction. Let's first write it as 1 by putting it over top of 1. And then I'm going to go ahead and rewrite it so that it looks like a multiplication problem. So the first fraction stays the same. Change the second to multiplication and flip that second fraction. Now we're going to go ahead and factor each piece. So again, you'll notice top left here, it's a trinomial, but it's a trinomial with an a value greater than 1. So up here, I'm going to show the work for this because we know that takes a little bit more work to break that apart. So again, when there's an a value greater than 1, we still need to add the b. So the b value is 1, but we need to multiply to a times c. So we do 6 times negative 15, it's negative 90. The two values that do that are 10 and negative 9. So what I'm going to do is I'm going to rewrite this problem with those two values in my diamond, group them. So again, you take the GCF out of each group. So correction there on the first group. Make sure you do take out the right one. We're going to take out a 2x, not a 3x. Be left with 3x plus 5. Second group, we're going to take out a negative 3. and then we're left with 3x plus 5, which means when I write out my final factors, I'll have 2x minus 3 and 3x plus 5. That's how that'll break apart. So my top left will be 2x minus 3 and 3x plus 5. That is my top left. Bottom left, much easier. It's one term. Top right, much easier, one term. Bottom right, the only thing I need to do is take out the GCF of x, and I would have left over 3x plus 5. Again, treat it as one big fraction. The 3x plus 5's cancel, and that's pretty much it. So all I can do is combine it. So in the top, I'd have 1 times 2x minus 3, so it'd just be 2x minus 3. The bottom, I have 4x squared times x. That would turn into 4x cubed, and that is my final solution. So in short, there's a lot of factoring that you have to be able to do. We're going to use all those factoring strategies that we've used basically all year long. They're going to come into play while simplifying all these problems. That's how we go about simplifying rational expressions when you're given one fraction. If we have two fractions, we're going to be multiplying and dividing. Again, it takes lots of factoring, lots of canceling, and lots of simplifying. You're going to learn soon enough how to use that as well when we do addition and subtraction and learn those processes in a future lesson.